Okay, everybody. Sorry to do this again to you, but we're going to do the best we can and catch up next week. What we have here today is we're just going to talk quickly about something called an exterior angle theorem, and then just quickly go through some area of a triangle. Just make sure that we're clear on that, and then put it into bigger pictures like you see in the last example here. Okay, so the exterior angle theorem is this. If I gave you I'm going to give you a couple triangles and I want you to take a second and find out what I'm marking as x. So say that that's 90 and that's 40. And if this is 30 and this is 70, what's x? Okay, and if this is 30 and 40. Okay, what's x? Okay, so take a second, pause the video, and then play it just to check your answers, and then I'm going to ask you a question. Okay? Okay, so hopefully you had time to do this, but basically what I'm assuming that you would do is that you would say, all right, well, this is 90 and that's 40, so I'm going to add those together to get 130. Subtract from 180 to get 50, and that's the interior angle there, and then use its supplement to find out the exterior angle there. Okay, probably similar to the next triangle, you're going to add up 70 and 30. You get 100, which leaves that angle over there to be 80. Then use its supplement to find that to be 100. Last one over here, 30 plus 40 is 70. You subtract 180 to get 110. I know that doesn't look like 110. Okay, and then you use its supplement to find that exterior angle to be 70. Okay, so if we were in person together, I'd probably throw like 5 or 6 of these on the board and say, not 6 or 7, just 5 or 6, and say like, what's the pattern, if anything, that you see? Usually a few of you will find that pattern so that we can share with the class, but that pattern is that if you add these two angles together, it will always equal the exterior angle. So if we add 40 and 90 together, that equals 130. 70 and 30, it equals 100. 30 and 40, that equals 70. So this is called the exterior angle theorem. It is not a fluke. It is not anything. It's just a property of triangles and something super nerdy, but something super cool that happens when you have an exterior angle of a triangle, okay? So when we're talking an exterior angle, we're talking about like an extension of a side of a triangle, okay, where you have that exterior angle. And that exterior angle is going to add up or be the sum of the two interior angles. So not its supplement, not that one, okay, but the other two angles. So in this box it says exterior angle theorem. Draw yourself a picture, and it doesn't have to be a certain type of triangle. But what I would do is, just so that I can look back at my notes, I'm going to label all the angles in that picture and just remind myself that if I add A plus B, those are the two interior angles, this is going to equal angle D. Okay, now, most of the time, if it's just numbers, you can always use like the sum of the triangle and then subtract from the supplement, just like you did for those questions probably up above. But if you have expressions, you might want to use this shortcut, okay? So again, in example number 5, if we're using the shortcut, we're just going to add 40 plus 80 to be 120. Pretty straightforward, right? Okay, same thing in example 6. If we're trying to find this measure of angle 3 out here, I'm going to add up the two interior angles, so 43 plus 22 is 65, not 67, and that is the measure of the exterior angle. So you're just eliminating that one step, which will save you some time, okay? So like I said, if it's just numbers like the last 2 examples, life gets pretty easy, and you can do it both ways, where you can find the third angle of the triangle and then find the supplement. But say it's like an example number 7 where it's not just plain old numbers. Okay, if you were to do this, you would need to write an expression for that last angle of the triangle and say like 180 minus both of those, and then you got distributing negatives and algebra gets messy. But if you remember this theorem or this property that triangles have, we can use the same thing to solve an equation, we can say 52 plus 2x plus 12 equals that exterior angle of 5x plus 4. Okay, so we're going to add up this and solve. So I recognize I don't have x squared, I just have x's. So I'm going to move things around. I'm going to get 60 to equal 3x, and x equals then 20. Okay, so just making sure that we're answering the question of finding angle MLN. MLN is right up here. So we're just going to plug in 20 into angle x, or into x in that angle. So 5 times 20 plus 4 is 104. Okay, so again, normal numbers, do it either way, but if you got expressions, that's probably the most straightforward, easiest, less algebra, less chances to make mistakes way to do it. Okay. All right, so now in area of triangles, which is the next thing that we're going to talk about. So if we were in person, this would be different, but I would give you, just a bunch of triangles and start with right triangles and say, okay, well, how do you know what the base and the height are? Because that's sometimes a little tricky for kids to verbalize, like, well, I just know it. Okay, well, the base and the height of a triangle are always what is a right angle. Okay, it's the two sides that meet at a right angle. So in a right triangle, that's pretty simple. Those are the two legs. Okay, so if we were to find the area of this triangle, what we would need to do is to ultimately find x. So if we have two sides of a right triangle, we would go do Pythagorean theorem to find the third. So I'm going to do that just real quick here. Okay, this is not a triple. I would check that first. 9 and 14 are not part of the same triple, and I can't reduce them by anything. So I'm just going to go ahead and do Pythagorean theorem. And I'm left with the square root of 115, which I'll just, spoiler alert, you can't break down. Okay, so we'll just leave it as a square root of 115. So if we're finding the area of this triangle, area of a triangle we find is taking 1/2 times the base times the height. Okay, you might have seen it as base times height divided by 2 as well. So either way, however you think about that is totally fine. But what's important for me today, moving forward, is that you understand that the base and the height are the sides that meet at a right angle. Okay, in a right triangle, pretty simple. So if we're finding the area of this triangle, we would say, okay, well, here's the base, here's the height, I'm going to divide it by 2. Now, just remember properties of roots. You can't multiply numbers that have roots and numbers that don't have roots. So to multiply 9 times root 115, we would just smush them together and leave it like that. Okay. Okay, now what happens if it's an obtuse triangle? So no longer a right triangle. When you have an obtuse triangle, you're still looking for sides that are perpendicular, okay? So if I'm trying to find the area of this obtuse triangle there, what's tricky is that none of those sides are right, okay? Could we draw in a side in between, like in the middle of the triangle? Absolutely, you totally could, okay? We are just missing both of those links though. We'd be missing that side, and now we're missing the height, okay? So while you could totally do it, I just don't know if you are given enough information in those problems to find that out, okay? Something to remember, or just like recognize the similarity, is if you've ever been on an airplane, they always tell you like the height of which you're flying, or the altitude. Well, the height or altitude is just what I just said. It is just the height of an object that's straight down to the ground. So sometimes the height of an object will fall outside of the triangle. Okay, where like this is where they're going, but this is still considered the height no matter where you are. Okay, so if we're trying to find the area of this obtuse triangle here, while 7 is the base, it may not connect to the height, and that's okay. Okay, the base and the height don't necessarily need to touch, and they won't touch in an obtuse triangle. So if we're finding the area of this triangle, we would need to find the height, but you might be able to see that, hey, we have, whoops, I don't want to do that. We have this little triangle here. Okay, we've got a leg of 3 and a hypotenuse of 5. You can do Pythagorean theorem, or that triple is a 3, 4, 5. So if I were finding the area of this triangle, I would take the base, 7, multiply it by 4, and then divide it by 2, which will equal 14. Okay, so again, the base and the height don't necessarily have to touch. Okay, and they won't touch necessarily in an obtuse triangle depending on what you're classifying the base as. Okay, now if we flip it over and like drew that line in between, okay, then they would touch, right? We would say that that's perpendicular. But sometimes in an obtuse triangle, your base and your height will not touch, and that's okay. Okay, I'm going to come back to this because there's a lot of properties with an acute triangle that I want to just like more talk about in person, okay? But most of your homework today is just really about right triangles, and that's it, okay? This one, I would say give it a try. I would say pause the video, give it a try, read through your givens, mark your picture, do all those sorts of things, play it, and I'll obviously go through it. But I would definitely say, like, let's pause the video, try this one on your own. Okay, so hopefully you had a chance to try this here. I'm going to go through the givens here. So ROSY is a square. So when I read that, I think, okay, if ROSY is a square, I know all sides of a square are equal, so I'm going to mark them equal. I also know that there are right angles in each corner, so I'm going to mark those too. The other thing that I notice now is that I've got right triangles everywhere, right? So I think, ooh, right triangles. If I'm after area and perimeter, I need to know lengths, which means, ooh, probably Pythagorean theorem. Okay, so if I keep going, FS, this is 14. Okay, and Y will bisect FS, which means it's in the middle, so that split that up into 2 equal parts, so that's 7 and 7. So that's 7, that's 7, that's 7, all of those are 7. YT is 24, and then I recognize, hey, I have a right triangle here. I have legs of 7, 24. You could do Pythagorean theorem, but you'd probably be tempted to pull out your calculators. That last leg is 25. It's just a triple. Okay, we know that these triangles here are isosceles, so that means this is 25. And then eventually I can figure out those two sides because those are the same. Okay, if I'm after perimeter of this figure, perimeter is just the distance around, so I'm really only missing one length here. And if I recognize that, I see I have a triangle and I have 2 legs of that triangle, so I can do Pythagorean theorem to find that third side. So I'm just going to quickly do that for you. This is will total to be 98. If you square root that, that's 49 times 2. And so that's 7 root 2. So perimeter, if you add up all those sides, 25, 25, 7, 7, and 7 root 2, you'll get 64 plus 7 root 2. Okay, area, you can look at this in a lot of ways. Most of the time, kids will just see this problem as just a bunch of triangles. So if you find the area of one of the triangles, you can copy it on over. Okay, the area of one of these little top triangles is 7 times 7 divided by 2, which is 24 and a half. So all of these are 24 and a half. And then this bottom triangle would be 7 times 24 divided by 2, which is 84. And each of those is 84. So then area will be 241.5. Okay, I know that was quick. Here's what I'm going to ask you to do. There's a worksheet in Schoology. Give it a try, do the best you can, work together on it. There's an answer key in there too. We'll come back on Monday next week and kind of recap everything, see where we're at, and if we can write equations of some perpendicular bisectors and stuff like that, we will. Otherwise, we'll just keep going with area and kind of recap that. I told my classes yesterday, but I'll also tell you guys this. We will not be having a final exam for this class. We are just going to be taking our Unit 2 test during the final exam period. Okay, so next week I'll see you 3 days. Monday, we'll just like recap, see where we're at. If we can do writing equations of lines, some more we will. Otherwise, we'll just keep going area and perimeter and just kind of wrap up and clean up some of the things that were discussed today in this video. Wednesday will be a review of whatever we decide to finish covering in this section. And then Friday will be your last quiz. Okay, so we will take a lunch that day on Friday. All right, and then I will see you guys Tuesday for a day of a Unit 2 review. And then for you guys, I will see you the second day of finals, which is Thursday, for your Unit 2 test. So no final exam for you guys, just a Unit 2 test. Reach out if you have any questions about that. That can't wait until Monday. Otherwise, we'll definitely talk about this on Monday.